and talk about domain. When we're concerned with domain, we are concerned with what we are allowed to plug into the equation. There are two questions we're going to ask ourselves every single time. There's two problems that can occur. The first problem is the problem of an even root. So that would be like, for example, a square root of x. That could be a problem because what are we not allowed to plug into a square root? We cannot take the square root of what kind of a number? A negative number. Taking the square root of a negative number gives us imaginary answers. So if we're trying to avoid having imaginary answers, we would want our x to be greater than or equal to 0. If x is 0 or bigger, we don't have any negatives, so we won't have any imaginaries. That's the first question we ask ourselves. Is there an even root? So it could be a square root, it could be a 4th root, a 6th root, an 8th root, whatever kind of root it is. If it's an even root, it has problems. The second question is if we have division with x in the denominator. So something like 3 over x. What are we not allowed to divide by? 0. So x can't be 0. Okay? So we're going to ask ourselves these two questions when we consider domain. When we consider domain, we need to consider the domain of both originals and the final answer. So, 2 times x to the 1/2, the f function. Does it have any even roots? Remember that a root doesn't always look like a root? Sometimes a root can look like a power. How could I rewrite 2x to the 1/2? We learned the other day that those fraction exponents, the top is a power and the bottom is a root. So we could rewrite that as a square root of x. So we do have an even root. So x has to be greater than or equal to 0. Do we have any division? No. I mean, we have that fraction of a half, but we're not dividing by x. In g of x, do we have any even roots?
Yes.
Yeah, it has that same thing. That 1/2 power is really a square root. So it has the same domain. X is greater than or equal to 0. Our final answer for this one was negative 4x to the 1/2. Does that have any even roots?
Yes.
Yes. Does it have any division? No. So now what we do is we look at the 3 domains that we got, and we want to be as restrictive as possible. 3 of them are the same, so it's just our domain. But if they're different, we're going to have to think about what excludes the most stuff, and that's what we want. Okay, we want to be very exclusive here. So like I said, it's probably going to feel a little uncomfortable because this is brand new. We're going to do lots of examples. We're going to do these 4 examples and more examples. So we'll be okay. So 2x to the 1/2, that's the same as it was last time, so we don't need to rethink our f and g. Our final answer for this one was 8x to the 1/2. Does that have any even roots? Yes. Does it have any division by 0? No. Question?
Yeah, I don't understand where you got the x is greater than 0.
Yep, we're looking for even roots. And sometimes fraction powers make an even root. Remember, a fraction power, the bottom is the root and the top is a power. Mm-hmm. So we could rewrite x to the 1/2 as the square root of x.
Yeah, I know that, but I don't understand where you
So that's an even root, and we can't plug negatives into a square root. Like if I try to take the square root of negative 9, I get an imaginary number. Mm-hmm. So if we're trying to avoid having imaginary answers, we want to let x be 0 and bigger, not any smaller than 0. So we're saying x is only allowed to be 0 and up so that we don't end up with imaginary answers. Okay. Let's look at the multiplication. Here our original functions are different. So we have to consider these original domains again. 3x. Are there any even roots there? No, there's no roots at all, no powers at all. Is there any division? No, it's 3 times x. So there are no problems with this. That means that x can be anything x wants to be. I could take any number and multiply it by 3. So in terms of domain, we say that that domain is all real numbers. We've used this symbol before this year. That r with the extra line is how mathematicians say, let it be whatever it wants to be. There's no restriction. G, does it have any even roots?
Yes.
Yes. That 4 in the denominator is really like a 4th root. So we have an even root there, which means we don't want x to be negative. We're going to make it be 0 and bigger. So there we're starting to get some restrictions. Our final answer was 3x to the 5/4. Does that have any even roots?
Yeah.
Yes. So we again have x is greater than or equal to 0. Do we have any division? No. So now our domains are different. So they're not all our answer. What we want to do is combine them to make this as exclusive as possible. If x isn't allowed into one of them, it's not allowed into any of them. So all reals, that lets everybody in the door. The other two are the same, and they don't let some people in. They don't let the negatives in. That's our answer. Okay, we want to take them one, or combine them to make it as exclusive as possible.
Almost like the answer to all the questions greater or equal.
If there's
They're always.
and the denominators, if the denominator's odd, that would be an odd root, like a cube root, and that's not a problem.
That's not a problem.
Odd roots are not problems. I can take the cubed root of negative 125. It's negative 5 times negative 5 times negative 5. So odd roots don't have problems, but even roots do.
So.
We'll do more examples. When you're doing division, it is important that you consider the entire process even before you did your simplifying. That's actually what we want to check the domain in is before. We did our division last time and we said that this was going to be our final answer. When we think about domain, we want to go back to the beginning before we did simplifying. So in that, are there any even roots?
Yes.
Yeah. So x has to be greater than or equal to 0. In that original, before I simplified, is there any division?
Yes.
Yeah. I'm dividing by an x. So what can x not be?
0.
I'm not allowed to divide by 0. So if x is supposed to be greater than or equal to if x is supposed to be greater than or equal to 0, but it can't be 0, then what does that leave me with?
X is greater than.
Just greater than 0. Okay? Now, we have 3 different domains. We want to be as exclusive as possible. Which one of those cuts out the most stuff?
The last one.
The last one. So that's going to be our domain. We want to be as exclusive as possible. Let in as little as possible. Let's do some more. So, let's say we have 2x squared, well, the fourth because that's what I'm writing, plus 3x squared. Are there any even roots?
Yes. No.
Any even roots?
Yes.
Roots?
No.
No, there's even powers, right? That 4 and that 2, those are powers, but they're not roots because they're not fraction exponents. So there's no even roots. Is there any division? No. So there's no problems with that one. What's our answer when there's no problems?
All numbers are good.
All real numbers. Let everything in. We can plug in anything we want to that one. Let's try x to the 2/3. If I write 2/3 as a power, what does it become?
X squared cubed root of x squared.
Cubed root of x squared. Are there even roots?
Yes.
The 3
No.
is the root, and it's odd, right? Odd roots are not a problem. You can take an odd root of a negative number. So this does not have problems. It means its domain is all real numbers.
So the
Yep. Well, you have to do the arithmetic portion we did first and this. So you'll have to add, subtract, multiply, divide, do this as well.
But is there a way you can get only a negative? Like x is less than 0?
No. Let's say I have 4 over x plus 1. Are there even roots?
No.
No. Is there division?
Yes.
Yes. Now be careful. What can x not be here?
0. A negative.
What's the problem?
X can't be negative 1.
X can't be 1. What would happen if x was negative 1?
You mix it up.
Then I'm dividing by 0, and that's the problem. It's not that that x can't be 0. Fraction can't be 0. So if x was negative 1, that would make the bottom of the fraction 0, and that's a problem. So x can't be negative 1 in this one. How about x to the 3/4? Do I have even roots?
Yes.
Yeah, the denominator of 4 is the root. That's even, so I have even roots. Do I have division?
No.
No. So what's my domain?
X is greater than x equals 0.
You guys are getting it. One last one. Let's say I have 3 over x to the 3/4. Do I have even roots?
Yes. Yes.
Yes. Do I have division?
Yes.
Yes. So combine the ideas, and x has to be just greater than 0. It has to be positive because of the even root, and it can't be 0 because I'd be dividing by 0. So we combine those ideas together.
This is only with multiplication and division.
Or adding and subtracting, like the very first example had adding and subtracting in it too. So it's in 7.3, but it's just the night 1 portion. The night 2 portion is about composition of functions, and we'll talk about that tomorrow.